Hello. Okay. I hope you can hear me. Just confirm once. Hey, hello. Okay, fine. So let's start. Say hello. Said hello. Uh, is it not audible? Can hear you? Okay, cool. Fine. So let's start. Mm, this one. Okay. First of all, welcome to the stream. So this stream is going to be about multi-threading again, as you can see on the right side of the screen. We are on the part 5, the last part, and we'll be doing problems 12 to 15. Okay, 4 problems. Cool. So let's get started. And this GitHub repo is where all the problems are. So if you guys want to do it along with me, you can simply clone this project and do it. I have already committed the question set. The answers is in a different branch called solutions. So if you want the answers, you can go see there. I have already committed answers to all the easy questions. I'm doing the hard questions now. Once the hard questions are done, I'll be committing them as well. Okay, excited? I am also excited. Fine, let's start. So 12th question. Scheduling with fixed delay and output. Okay, so input is number of executions, delay milliseconds between executions, and true is if actual delay is approximate configure delay within a margin of error. Okay. How do so there was this delay example already, if you remember. Uh, it was there in one of the yesterday's questions, which I kind of forgot what it was. Let me go check it back. Hey, okay. This one, right? The schedule executor. Okay. The schedule reminded me the question, actual construct. So let's do it with scheduled executor. Schedule executor is it? Oh, I wrote the spelling of schedule wrong. Schedule executor service equals new schedule executor service dot. There's a new class. I mean, you have to implement this, the runnable command and the delay. Okay, fine. Oh, there's a lot of things you have to implement. Okay, that's a lot. Okay. So I think this is wrong. You probably have to give executor service. New schedule thread pool, right? Got it. So let's give 4. But there was also, what's the mistake here? Mm, Can you explain the question again, please? Okay, sure. So they're asking to schedule with a fixed delay. Number of executions and delay millis between executions is the input. And the output is true if actual delays approximate configured delay within a margin of error. Okay. So um, let's go to notes. Fine. So they are giving two inputs, right? One is number of execution. Let's say number uh, number is equal to 5. And then they are saying delay. Delay is, let's say, 1000 milliseconds. Now, yeah, that thing. Now they're asking whether whether it actually executed those many times. First of all, did it execute 5 times? And oops, sorry, yeah, executed 5 times. And then they're asking to see if the delay between each execution is actually 1000 ms. If they give the input as 1 second, is it actually executed between 1000 millisecond with a small margin? They said like maybe you can have a margin of like 50 millisecond in between. So it's like plus or minus 50 millisecond. So the thing with schedule executor is you can ask it to run a number of times. So you start an execution, uh, you start a job, and then you can say after that wait 1000 more millisecond. Okay, again execute the job, wait 1000 more millisecond. So you can have like a cron job kind of thing. If you know how cron jobs work, for example, backup jobs run like um, yeah, 5 tasks we have to run with delay. Correct. So it's not 5 tasks, it's one task running again and again. So let's take an example of a backup job. You have to continuously back up the photos in your Google Photos. So we can set a schedule like every day night at 10 p.m. You have to schedule, run the backup job. So that becomes a 24 hours window, right? So all that the program is asking us to do is check if the delay is actually 24 hours. It can even be like 23 hours and 59 minutes, or like 24 hours and 1 minute or 10 minutes. It doesn't matter, right? The small margin is fine, but it is just one task running within this interval. Okay, so that's what we are looking for. And for that, we have this thing called scheduled executor service, which we saw yesterday, but I forgot. So I think it was in the easy problem. So let's go to the easy problems. So if you guys want to see the easy problems, they are in like part 1, 2, 3. 1 to 3? Yeah, 1 to 3 or 1 to, yeah, part 1 and 2 are the easy problems. So this is how we did it. So even if you see here, let me enable word wrap. You see there is only one task where we are just incrementing a counter, but we are running it at repeated rates, which is like, let's say every 200 millisecond, we are incrementing the value of this counter. So something like that, right? So this is what we want. Okay, so this schedule executor service equal to executors dot new single thread schedule executor. Now where is the um, scheduling? So here it is. So schedule at fixed rate is what we want. Okay, so single thread schedule executor, right? Why does this show error? Let me do one thing. I'll cut that and I'll write it again. Okay, we have the service now. And if you remember with the executor service without schedule, let's say I wrote just executor service, you can call the execute or what is the other one? Submit, either of these. But in schedule executor service, it runs like maybe 2 days later or sometime in the future. So you can't simply just submit it. You have to say when it should be submitted also. That's why you have like svc dot submit schedule and then you say when it should be scheduled. So you have a task here, and you have the initial delay and how long it should work. And if you want to keep running it, so that is where you have the schedule at fixed rate. So you have the initial delay and how long it should run. So you can even say that it should run after 1 hour and it should run for 1 day. So let's say what's the time now? 4:20. So it will start running at 5:20 and then it will keep running at 6:20, 7:20, 8:20 until tomorrow 4:20. Right? So that is sorry, tomorrow 5:20. So that's how it is. And there is one more. Which one do we want in this? Delay, number of execution and delay between executions, right? Let's do that. This one. So we have what we need to execute first of all. Oops. Okay, that's the first thing. And then what is the next item? Show. Okay. The next thing is initial delay. So initial delay and the further delay we'll set it to the same time. Okay. So I'll explain what that is next. So delay. Okay. And then the number of executions. So where is it? So I'll explain the concept of initial delay and just a delay. So initial delay is when to start. It's the start timer. And delay is the interval. Right? Those are the two ones, right? Correct. So let's say my main thread, right, which is actually spawning all these other threads. In that, I'll say after 1 hour, start the scheduled job. Okay, and then I say to it after for every 10 minutes. So what it does is for every 10 minutes, it keeps running it. So that's what I was saying, right? So now let's say the time is 4:20 p.m. Okay, so I say after 1 hour it should even start. So 5:20 only it will start, and then it will run every 10 minutes. So it will run again at 5:30, 5:40, and so on. Okay, so this gap in between 4:20 and 5:20 is the initial delay, and this gap between each execution, right? This is the delay. So this is the difference. Okay, fine. So I hope you can see that. Now, moving on. So now I have set delay and initial delay to the same thing. So let's say, let's go to the test case and see what is there. What is it called? Scheduling with fixed delay example. So scheduling with fixed delay. This one, test scheduling with fixed delay example, right? So they are setting 3 tasks should be run every 200 milliseconds. So I'll then keep running the tasks every 2 milliseconds. Okay. Sorry, 200 milliseconds. Now, it's not 3 tasks also, it's single task which should be run 3 times. So number of execution. So we should even calculate right. So once we figure out that it has completed 3 times, we should stop it, right? We should make sure about that also. So how do we do that? That is not there in our method. So that is why they have given number of execution. So now if you leave it like this, it will keep running forever. It will never stop. So we have to figure out how we can even stop it after this number of executions, which is 3 in our case. So how do we do that? Hmm. So let's see what other functions are there here. Hmm. That doesn't have anything. Um, okay, let's see if there is some, get. No, there's no get. Hmm. What is this return? Oh, it returns a schedule future. Hmm. Okay, let's say we got a schedule future from this. Shade of Boolean. Let me return a Boolean here. Okay, return true. Okay, what is wrong? Void methods cannot return a value. Okay. Okay, so I don't think I need to return anything here. What is this? Cannot confirm schedule fetcher. So I think this is just object. No? Is it, what is it? Okay. So you got a future. I wish they don't ask multi-threading questions in my tree. Yes, me too. But we have to know these things. So future dot. Oh, I got it. So when you do future dot get, you get the answer, right? But you get answer for only one instance. What if, so they asked three executions. So you have to do future dot get thrice is what I'm assuming. Let's try it. Okay. This will obviously throw exceptions, which we don't care about. Ignore, ignore. Okay. So we do a future dot get, which will give us an object. I don't even know what is there in this object. Let's see. It's just an object. Fine. So we don't care about what it is. We just need to see now future dot get delay in milliseconds. Okay. Right. So we have to do it thrice. And after that, we just do future dot cancel. True. Because after that, we don't need to run it anymore. Then we do svc dot shutdown. Okay. And svc dot await termination. We just wait for 100 more milliseconds to for the thread to get stopped. We'll surround this also, and we don't care about the exceptions. Okay. So true if actual delays approximate configure delay within the margin of error. So we have to store all these values in a list or something. List of long delays, actual delays. I don't even know if I am doing it right. We will see it in the end. Okay. Dot add All I hope is that it doesn't, hey, right. All I hope is that it doesn't give the delay of the next item that would become 500 or whatever this. What was the delay here? 200 again or 0 again. Okay, so let's see. We got all the delays. We cancel, we shut down. Now we check for delays. Dot stream dot filter a delay dot count. Okay, so what I'm doing is I will take a delay and minus it from the actual delay. Where is it? Delay millisecond minus this. Okay, and I'll see if it is less than or equal to, let's say 50. That is our delta. Okay, what's the if I am writing in JavaScript syntax. Okay, if this, then return true, else return false. Okay, now another thing to note here is this might become negative also. In that case, I need to do apps, math.apps. Okay, fine. So I filter out everything. Oh, so if it is less than 50, we filter it out. So we don't care. False. So it should be ulta. Right? So if it is within our delta, we don't consider it. We ignore them. But if it is outside our delta, then we mark them as actual, mark it as an actual problem. And here we will have a list of, what do you say, long again, problematic delays. Okay. Now, what is the problem here? Oh, it's just a count, right? Okay, got it. Problematic delay count. So all we have to see is problematic delay count is greater than 0. So if there is even one problematic count, then we are having an issue. Okay, this might be a long answer to a short kind of problem. Let's execute and see how it goes first of all. Scheduling with fixed delay example. Where is it? Oh, why is it taking so much time? Okay, I think there is some problem with the fine. Let's do one thing. Let's stop this and we'll cancel these shutdowns. The shutdowns are causing interruptions for us sometime. Nope, that's also causing problems. Then I think it's a problem with cancel. But then I have to cancel it. There is no other way. What if I set this to true, false? Okay, fine. Let's now go and ask our ChatGPT. What is wrong? The main issue with your code is misuse of schedule feature returned by schedule feature. Why it doesn't work? According to Java's documentation, represents the entire series of repeated execution, not a single run. Okay. Its get method never completes normally because oh, it only becomes done if you either call future or cancel. Hey. So where is my get? It's here. Hmm. So I mean, I'm trying to do that only. So future dot get after 3 executions, I want it to get cancelled. But then they are saying that it will never end because it indefinitely runs, right? So what should I do? Will block forever, waiting for, yeah, correct. So your loop never progresses past the first iteration. So they are saying don't call it here. Hmm. So measure inside the runnable. To record actual delay between runs, move the timing logic inside the schedule task itself rather than depending on schedule future. So scheduling with future. Hey, they're just waiting. They're not doing anything else. So where is this count happening in number of executions? Oh yeah, they're just doing that. I thought there is an actual way to count the number of executions. They're just multiplying it and just waiting. Okay. Okay. So what we have to do here is we did the future right, and this actual delays, they're saying to this is wrong. Okay. So before this, we have to wait long enough for number of executions, and then you cancel and shut down or whatever it is, and then try this. So inside this body is what they're trying to, I mean, saying to do. Okay. So let's first declare long now equals system, sorry, system dot current time in millis. Um, oh, it's like the past. Okay, last. Okay, so last is this, and long now is again the current time, and then actual delay is now. I mean, dot add now minus last. Right now is always larger, and then set last to now. Okay. So this is why they did it as an array. Okay. Okay, fine. So this is a nice hack. I didn't know that you can do this. You just declare it as an array so that you can use it internally. Okay, so one more thing we have to make sure is this should be concurrent. So collections dot, what is it called? Synchronized collection. Synchronized list. That's it. New array list. Okay, now that list be thread safe also. So every time we are calculating the delay as whatever the now system time is minus whatever the last thread got executed. Okay. Okay. I hope. We didn't still do this. We have to wait. So if I have to run it number of executions of time, then I have to wait that much time. So thread dot sleep number of executions into delay amount of time. Okay. Hey, what is delay millis amount of time, and this throws an exception surrounded try catch, and just for the sake of it we will give it like 50 more milliseconds extra because of all this calculation that should happen, right? So maybe that takes some extra time. Now let's run it and see what's happening. What is this called? Scheduling with fixed delay. Test scheduling with fixed delay. This failed. So it should be true, but we got false, which means let's print the actual delays and see, or let's debug the actual delays and see how much time it is taking. Okay, debug. So it took 207, 200, and 203, which is almost around what we wanted, right? Our time, what do you say? Our delay is 200 millisecond. Each took around 7 or 3 milliseconds extra. And what I am trying here is 200 minus 207 should be less than equal to 50. Correct. If that is true, then I am returning false, which means I don't want to add it. Okay, then how come the count became bigger? Let me go here and see. It is 0, right? Oh, it should be greater than equal to 0. Classic mistake. Greater than equal to 0. No. So there is no problematic delay count. So that should be correct, right? Getting confused. So we got 200, 207, 203. Okay. And our delay is 200. And the delta also gave us 0. Now our question says true if actual delays approximate configure delay within a margin of error. Okay. Which means there are no problematic delays, right? Right. So we see if it is equal to my. Okay, so we passed that example. Test scheduling with fixed delay example is a pass. Awesome. So we even checked how much time it is taking between each. So we even saw that it is actually taking 3 executions. So the number of execution that we expect that is actually getting triggered also. So that's nice. So one thing we learned here is that dot get for a schedule execution never returns, which makes sense. And we are not supposed to do dot get. Future dot get is incorrect. Okay. And I'm pretty sure this was a very large problem. So let me go through it once again. Okay. So the question, let's explain the question once again. You are asked to run a single task. Okay. It's just one task. And you have to run it 3 times. Okay. Every 200 milliseconds. Okay. This is your question. Fine. Now they want to check if each task actually ran with a delay of 200 milliseconds. So let's say, each task, no, each execution. So execution 1, execution 2, execution 3. Okay. So in between these 3, there should be 200 milliseconds. 200 milliseconds. Okay. So they are asking if this gap is correct or not. Now, how do we check this? Since this is a scheduled task, the dot get on the future, right? The future dot get will never return true. It will never return actually, because they are running indefinitely until we stop it. So, okay, right. So unless we stop it, it keeps running indefinitely. So what should we do? We should figure it out within the execution itself. So that is why inside the task itself, we are doing the calculation. So outside the task, we are having a variable saying what is the current time, or it's like the past time. Past time. So past time is, let's say, 4:47 p.m. Okay. Now inside the thread, the first execution, let's say, happens at 4:48 p.m. Okay. And let's, for the sake of understanding, assume that the delay is 1 minute. Okay, not 200 milliseconds. Let's assume it is 1 minute. Now it ran at 4:48 p.m. So what is the correct difference? 4:48 minus 4:47 is the difference. So it ran in 1 minute. Okay, so we got that gap correct. And then we have to set the past to the current time, because that is when the last thread executed. Okay, the last execution happened at 4:48. So this changes to 4:48, and that's it. Then the next execution happens. The next execution happens, when should it happen? It should happen at 4:49 p.m. right? Then again the difference in time becomes 1 minute. So now we have to set that as the new time. So 4:48 becomes 4:49, which is the last time it happens. Now every time we are calculating this difference, right, we are storing it in a list, of long. We are storing the differences. So it will come like 1 minute, 1 minute, and 1 minute. 3 times the thread got executed with this delay in between. Now we have to check if it is actually 1 minute between this also. And one more thing is, once it has run 3 times, we stop the the executor. So how to do that? We already got a future, right? The future object of that executor, future of it was question mark actually. We got a future of question mark in that. Once we have waited enough, so we know that how much is the delay between each thing. So if we wait 3 into 1 minute times, we know we need 3 minutes, right? So if we sleep for 3 minutes, we know that it would have run 3 times, right? It's just that logic. So once we have waited that long, then we do future dot cancel, so that the threads stop running. Okay, now the scheduled threads won't run anymore, they finished. Now what we are doing, we got this list here, right? This diff list, we take it after all this, And then we go through each diff, 1 minute, right? We go through each diff and see if it is actually 1 minute or somewhere in that margin. It can even be like 1 minute, 5 seconds, or like 1 minute, or it can even be like 59 seconds. Because there is not just these threads that are running in the system. There are other things also running which could, potentially take time. So that's why we should understand that also. Now, once we see that all of this is done, we actually did a stream calculation where we count the number of items that are not in this vicinity. So if anything is greater than, let's say, 50 millisecond for our case, because our scale was also smaller, it was just 200 milliseconds. So if we see that, we take the count. So if the count is greater than 1, or it's like, what do you say, if it's not equal to 0, eraser, if it is not equal to 0, it means that one of the thread failed our execution. It didn't pass through our this thing, delay, the correct expected delay. So once we understand that, then we just return it. So the return actually asks whether count is equal to 0 or not. So it should be 0 count. The count as in the invalid number of counts. The invalid number of counts should be equal to 0. If it goes anywhere other than higher than that, then it means that we are having a problem. So the problematic delay should be equal to 0. Okay, so that is question number 13. So if you guys have doubt with question number 13, just let me know. Let me minimize this. Wait, where did it go? Okay. Fine. Moving on to question number 14. Hey, how long is the stream running? 44 minutes. Okay. Fine. Then we will take a break and come back. Okay. Because it's been a long time. So we have just 2 more question left, 14 and 15 left. We'll do that quickly and end this stream. Okay. So carry on, guys. Take a break. Hello. Okay, fine. So welcome back after the break, and let's continue with question number 14. Okay, I hope my sound and everything is fine. If there is some issue, just let me know. Custom thread pool executor settings. Okay. Hmm. So custom thread pool executor. Oh, so this is with the thread pool executor thing. Mhm. Where we built a separate class which acts as a which extends the thread pool executor and takes tasks in it. Okay. Core pool size, max pool size, keep alive, and number of tasks. Okay. Oh, Diwali has started. They started cracking bursting crackers. So class worker thread extends, I mean implements, what is it called? Thread pool executor. Is it what it is? Hey. Huh. Mm, is this what it is? Nope, not this. So yesterday we did this as well. So there was a L0. So was it here? I'm pretty sure it was in the yesterday's one only. I remember writing an extra class. Was it in L1? Ah, here it is. Worker thread implements thread factory. Oh, this is the thread factory, but they are asking for custom thread pool executor. Okay, this sounds different. So there is one in executor service itself. Service svc equals executors dot new. Ah, here it is. New cache thread pool, and then they are giving the custom thing. Worker thread. I mean, new worker thread. Okay. Now inside the thread, I don't think I can see what is the pool size and all. Probably I can if I, you know, this one. So if I There should actually be a different thing. Ah, in fixed threads. So in fixed thread, I'll set that the core pool size is this and the max pool size is that. Right? It has number of threads. Creates a thread pool that raises a fixed number of threads operating off a shared unbounded queue. Using the provided thread factory to create new threads when needed. At any point, at most in threads will be active processing tasks. So at most means that is the maximum. Okay, so this should be not core pool size. This should be max pool size. Okay, and they will wait in, if additional tasks are submitted when all threads are active, they will wait in queue until a thread is available. If any thread terminates due to a failure during execution prior to shutdown, a new one will take its place if needed to execute subsequent tasks. So they are saying about all this, the queuing and waiting and all of this stuff. But then I'm not sure how to get all this data. Is it possible to cc.queue? No, there is a blocking queue somehow. Okay, fine. I guess we have to check Perplexity. So I'll sorry, explain the question meanwhile. So they're saying that we have to write a custom thread pool executor, and we have to monitor the resizing and queue stats. Okay, so that is what they are asking. So let's go back to our whiteboard. Okay, so any thread pool, let's say this is a thread pool, it will have a set size. Okay, and there are two concepts here. One is the what is it called, the core pool size, the initial size, right? Not this one here, the core pool size. The core pool size is the initial size. So let's say no, I'll also go with the max pool size, then I'll explain what it is. So max pool size is the maximum. So let's say I can have a maximum of 10 threads in the pool, but then I'll say the core is only 2. Okay, so although you have provision to run 10 items, I will initially allocate only 2 buckets, like 2 slots for the threads to run. And then as my buffer gets incremented, like let's say new items are coming into my pool, then I keep increasing up till what size? Up till the max pool size. So if this whole thing is 10, okay, I start with 2 and then slowly increase until I reach 10. Okay, so that's the whole concept here. Now, what they want us to see is if I am properly staying within the limit of 10. Because let's say now you are given 20 tasks. Okay, you started with 2. You allocated 2 tasks. Then you see that you need more space. So you keep allocating until you reached 10. The pool size became 10. Now your 11th task comes in. When the task number 11 comes in, there is no place to put it. So this is where we even noticed the yesterday's problem, right? With the different policies for when the queue is full, what should we do and things like that. So that is a different case anyway. So now what we should do, we should make all of these things wait. So 11, 12 and whatever is coming, this should be put into a queue where it is waiting to be scheduled and executed. So all they're asking is to see if this pool size never crosses 10 and things like that. I think that is the only metrics that we need to see, and we have to also make sure that all the other threads also get executed. Okay, fine. So let's see what is the answer for this, because I don't know how to calculate metrics for these things. Oh. Let me remove this as well. To implement the custom thread pool executor setting example method, you need to configure a thread pool executor manually. So I think that is the last thing we have here, right? No? Oh, this is thread factory. So they are saying you have to do a thread pool executor. Got it. So apparently that's a separate class. And dynamically observe its thread count and queue size while submitting multiple tasks under varying load condition. This demonstrates how core pool size, max pool size, and keep alive seconds and queue capacity collectively determine behavior. Okay, so this is the custom thread pool executor. Okay. We need a blocking queue, the work queue also. And then the policy is about policy they mentioned. Mhm. Mhm. Okay. So what they're doing is we are taking our own thread pool executor. All this time we were doing the system provided one. Now we are taking the thread pool executor, and inside it we are submitting the task that we want. And whenever we are submitting whenever we are submitting a task, we are also recording what is the pool size and the work queue size at that time. And we have to see that at any point in time, the queues should not be greater than 0. Hmm. And then what is this one? Pool size should not be greater than the core pool size that they give. Mhm. Okay, all of this because we are trying to execute things very shortly or like very fastly. Hmm. Okay, let's write this and see how it goes. So, uh, where is it? So, thread pool executor, right? So, thread pool executor exec equals new thread pool executor of all of this core pool size, maximum pool size, keep alive seconds, and work queue. Okay, so core pool size we got, max pool size we got, keep alive seconds we got, and unit is time unit dot seconds. And finally, we need a queue blocking queue of what is the type of runnable. Okay, queue equals new linked blocking queue. Okay, and we have to give this queue here. That queue is for storing items which cannot be processed. Okay, now what we do is let me just see what is the test case here. Which one is this? Custom thread pool executor, right? Custom thread pool executor, this one. So they're saying core size is 2, max size is 4, and what is this 10 and 10? Keep alive for 10 seconds, and we are executing 10 tasks. Okay, what I'll do for equal to 0. Okay, we will submit a task. Executed, submit. Some tasks, we don't care what it is, we'll just do 100 milliseconds sleep. Okay, nothing else. We'll execute because we don't need to look for the output. So I'm just saying execute. Okay, once this execution happens, we record what is the sizes of the queue. Okay, so exec dot get core pool size, right? We get the core pool size, and then we get the queue size also, queue dot size. right? We have to store this somewhere. For that, we'll create a data structure. List of, I think these are both long, no, integer, both are int, right? List of integer, core pool sizes equals new array list, and list of integer q u sizes equals to new array list. Okay, so we'll add this dot add and q sizes dot add. Okay, fine. So whenever any execution is happening, we are doing all this, and then we're letting it get executed. So for that, we will do thread dot sleep. Oh, or wait, we'll call exec dot shutdown, and then we'll wait for everything to complete. Await termination, and we'll wait for keep alive seconds. Seconds. Okay, we will throw this. Sorry, surround this try catch. Ignore errors. Now, the core pool size should always be under what are the core pool size we got. Okay, so for that, what we do, core pool sizes dot stream dot any match if any of value is greater than core pool size. Okay, so none of the value of the core pool sizes should be greater than this. So we'll see if it matches. Okay, so boolean core pool size exceeded equals this. It will return true if it got exceeded. And similarly, boolean queue sizes exceeded. Queue size of exceeded equals queue sizes dot stream dot any match value. Value is greater than 0. Right? So they say that the queue should also never be a positive integer like 1 or 2. Right? And finally, we return that both should be true. If even one of it fails, then our our code has a problem. Okay, let me run it. So custom thread pool executor settings. Where is that one? Custom thread pool executor settings. This failed. So let's see why it failed. So they are asserting true. And let's see what are the sizes. Let me come here, set a breakpoint and run it. I ran it instead of debugging it. Let me rerun it. This is one of the previous breakpoint. I'll ignore it. And this also is a previous breakpoint. I'll ignore it. Right here. So queue sizes is, oh, it keeps increasing 1, 2, 3, 4, 5, 6, 7, 8. And core pool sizes is always 2. So this is always 2, which is what we gave. But this queue keeps increasing, which I also expected to happen because when there is jobs running, says there is job schedule, the queue size is supposed to become big, right? So if you see the first 2 times, it didn't become big. It was at 0 only. But because our core pool size is only 2, the remaining things got scheduled, right? which is bound to happen. Now I want to understand how this thing is expecting queue size to be always zero. That's the question. Okay, let's see. It's because they gave a max pool size, which we are not utilizing. Where is max pool size? Right, maximum pool size. The number of threads to keep in the pool even if they are idle unless the allow core thread timeout is set. Interesting. So that is the only line which they have set. So if I set this, will it automatically become false? Then I want to understand what that does. Where is this? Immediately after declaring executor. Okay, I'll stop this and rerun it. No, that did nothing. Okay, then there is something else that is causing issues. So let me ask Perplexity, how do you expect the queue to be always empty? Hmm. When the number of active threads is below core pool size, new tasks trigger immediate thread creation without queuing. Only when the core pool size threads are busy, do new tasks. Okay. Hmm. Okay. So what they should have done, or like Perplexity should have done in its sample code is after it executes a work, right? It should immediately wait for that much time for the work to get completed. Then it can expect the queue size to be empty. But then it allocates something, and if it is immediately going to uh, allocate another thing, there is no space left, right? How will it do it? So let me try that. In here, I do thread dot sleep 100, right? After this, I'll do thread dot sleep of, let's say, 150. And after that, I'll allocate. I stop this debugger, surround with try catch. So now one task is allocated. It should run for 100 millisecond, but then I'm sleeping for 150 milliseconds. So by the time I come here, the that first task should have completed, right? So I should be able to throw that task away and pick the next task, right? Let me try that. Hmm. So now queue sizes, right? Queue sizes should be 0, right? See, because there was always a small delay which we gave to allow the work to be done. Now, one more thing I noticed in Perplexity is they gave a policy of about. So, this policy, if you remember yesterday's um, session, when you say about policy, it will simply kill whatever is there and then add the new item, right? So, let me try that. Okay. I added an about policy, but I won't be sleeping here. So I'm not going to wait extra time for the thread to complete its execution. Now let's try what will happen. Hopefully, this will also give 0 because what it will just throw away whatever is there in the pool is what I'm assuming. Let me see. No, it didn't. So yeah, that has something else to do, I guess. So back to perplexity, I have some more questions. Huh. The question that I had was, we said max pool size, right? Why is the pool size never going below beyond the max pool size? Is it the number of threads per pool? So let's say they said 4, and here for maximum pool size, which is the maximum number of threads allowed in the pool. Hmm. Okay. Why is my pool size always constant and never increasing to the size of max pool size? Hmm. Interesting. So the max pool size. So let's look at this with the diagram. Um. Wait. We said that the pool's size should be only two. Okay, one, two, and this is our pool. Now we are also giving it a queue. Sorry, spam calls. Ah. Now we are also giving it a. Let me just cancel this. Ah, sorry for that. So we are also giving it a blocking queue. Okay. So whenever this queue is blocked, okay, there is no more space. We add those item to whenever the pool is blocked and there is no more space, we add those item to the queue. This is a queue. So what the concept is apparently, if at all um, there is enough space in the queue, it will always accumulate in the queue. Now let's say the queue got full. Okay, I said the queue can hold only maybe 4 items. Now when the fifth item comes here, I think that is where even the rejection policy and stuff like that happens. But no, not yet. Because I said the maximum pool size is 10, right? So it will again keep filling items here. Now, when the 10 reaches and there is no space in the pool and there is no space in the queue, there is nowhere else for the task to go. That is where the policy, like the abort policy and stuff like that, comes into play. Okay, so this is how it is. That's why the pool size is never going beyond 2, even though we said that the max pool size should be 10. It would rather queue it because queue is RAM. So RAM is fine. It would rather queue a task than touch the CPU and mess up something there. Okay, so that's the point. Fine. So moving on. Where's the timeout? Did I remove the timeout? Yeah. And if I run this now, it should pass. Where is that one? Test. This one. Test custom thread pool executor settings. Okay. This failed. So why did this fail? I did something here, right? I forgot what I did. Okay. Hey, why is this still failing? Let me debug and see. Queue sizes is 0. Correct. What is the other one? Core pool sizes is always 2. That is also correct. Then what is the mistake? False. Oh, it's just false and false. So it became false again. So stop this. So how do I say it? So if this becomes true, it means, okay, so it should be not this. So this should have been false, this should have been false. So false and false becomes false, and the not of that becomes true, because we got nothing that is greater than core pool size, and we got nothing that is greater than 0. Okay, so if both are nothing, even if we get, let's say, one item became true here, then this will become true and it will fail the case. Okay, so let's play it again. It's debugging. Okay, so JUnit, and that passed. Test custom thread pool executor. Okay, fine. So with that, question number 14 is done. If you guys have doubts with 14, let me know. We will move to question number 15. Graceful shutdown with running tasks. Input is this and output is this. So number of tasks and use shutdown now. Okay. True if shutdown interrupts or cancel expected number of jobs and executor terminates correctly. Write code to shut down executor gracefully or forcefully and verify jobs interrupted. Okay. I think we have to write 2 then. Okay. So what they're asking to do now? Let me explain. How do I get rid of this small pop-up thingy? I don't think I can. Okay. If I move my mouse away, no, it still stays. Fine. So what they're asking, you create an executor service as usual. And you have 2 options here. You shut down or you shut down now, right? So when you call shutdown now, it immediately force kills it. If you do shutdown, it waits and force kills. Waits and then stops. It doesn't allocate any new task. That's the whole concept of shutdown. And you should, of course, await termination in both cases. Termination. So it's like saying, let's say you have a DB shutdown task. There's a database running in a thread, and then you are waiting for something to shut down there. So you have to ask it to, it takes a few seconds to stop, like maybe 20-30 seconds. So you can ask it like, wait for 20 seconds and then stop. So that is where the await termination happens. So even if you call shutdown, you are waiting for like 20 seconds for it to stop. And even then, if it doesn't stop, that is where you have the exceptions that it was saying. So what was the exception? They haven't specified it, but there is an interruption exception. So probably it will give a interruption exception. Okay. So we have to simulate this. Now, how do we simulate this? Okay, they have this use shutdown now Boolean. Based on that, we have to either forcefully or gracefully. So if they say you shut down now, true, then we have to call shutdown now. Otherwise, we have to just call the normal shutdown to gracefully shut it down. Okay, so makes sense. I think we have to just create a normal pool. Uh, executor service. So executor service equals executors dot single thread executor, and for yeah. Okay, and in the executor I'll like thread dot sleep of, let's say, 5 seconds. Okay, surround with try catch, and I don't care about the exceptions. Now, when I allocate this, this will already start working, right? So whatever is there in the thread pool now will be already working. So if I call svc.shutdown, so if you see the documentation of shutdown, it says initiates an orderly shutdown in which previously submitted tasks are executed, but no new tasks will be accepted. Invocation has no additional effect if already shut down, right? But in shutdown now, if you see, it says attempts to stop all actively executing tasks, halts the process of waiting tasks, and returns a list of tasks that were awaiting execution, right? So even if a task is running actively, it will try to shut that down as well. So that is the point of this. And this method does not wait for actively executing tasks to terminate. Use await termination to do that. Okay. Um, so they gave two things, right? So if where is that, use shutdown now, then you do svc dot shutdown. But if they give not, oh sorry, shutdown now here. Otherwise, you do svc dot shutdown. Okay. Now we have to wait. Now let's say we say svc dot await termination, and then I say I wait for like 100 milliseconds. Time unit dot milliseconds. Okay. Now this throws us the exception that we want, and which is the interrupted exception. Now, if an interruption happens, what should we do? Um, True if shutdown interrupts or cancels expected number of jobs. Okay. Now, since I'm sleeping for 5 seconds, I am expecting all the tasks should have been failed. So I will return what do you say, whether this should actually have given us a boolean, right? Hmm. This. So this should have given us the number of tasks that are actually not. So if you see the thing, returns a list of tasks that were awaiting execution. Okay. So let's hope that it gives all of them. Okay. Let's store it here. Awaiting. And if the shutdown happens, I need this outside. Okay. If an exception happens, I will see if size greater than, equal to num tasks, because I would have expected all of the tasks to have failed, to have interrupted. So that is what I'm expecting. Now, there is one more problem here. The awaiting execution might be null. So if awaiting execution equal to null, not equal to null, do this. Okay. So awaiting execution will be not null only if we force the shutdown. Okay. In the else case, shutdown happens normally, and then we return true. Okay, if shutdown happens normally, or I'll just put return true here so that it's a normal case. If none of this happens, that is when we return false. So it should have either returned true here after a graceful shutdown or returned true here after an interruption happening. But if it returns false, it means that something is wrong with our code. Let's try it, either with our code or with my understanding. So what is this method called? Graceful shutdown with running task example. This first one. It expected true but was false, which means it went to this point, right? So let me see. They're asserting two items here. So first time they are doing graceful shutdown with forced shutdown. Then they're expecting graceful shutdown with unforced, like graceful shutdown. So let's see which one failed. Let me put a debug point over here. So forceful shutdown, right? Awaiting execution. Where do I put it? Okay, I'll just put it here and then see what is happening. Okay, now step over, step over, step over. Awaiting execution returned 3 items only. Oh, so 2 items got executed. Okay, step over. svc dot await termination. Okay, step over, step over. So it's not even going into the catch block. So all we are doing is when we are killing itself, it got killed. So, right, makes sense. But the only thing we noted here is only 3 items are there, not 5 items. How did that happen? The answer to that must be somewhere here. We created a single thread executor and we assigned it 5 tasks, right? And each task is sleeping 5 seconds. Even in the worst case, if we say the first task is running, so it couldn't be interrupted. Even in that case, only 4 threads shouldn't be able to execute. Let me try one more thing. I'll stop this and I'll say fixed thread pool and I'll say only one thread. Okay, let's see what happens now. I'm assuming in the worst case at least 4 threads should be interrupted. Okay, step over, step over, step over. Yes, see, so in the worst case at least 4 threads got interrupted, right? Now how do I stop the 5th thread? It is not taking 5 seconds, right? 5000 milliseconds. Okay, let me do one thing. I'll wait for 50 seconds. Okay, let's see what happens now. Step over, step over, step over. No, it's still 4 only. So I'm assuming the first thread never stops. So let's see. Let's see what is the reason behind that. If I allocate 5 tasks, why does the incomplete tasks return only 4 always? Okay, let's see. Okay, attempts to interrupt running tasks. Yeah, which is the first thing. The currently running task which has started but is sleeping is not returned as an incomplete by discontinued in execution. Okay. The interrupted running task will return receive interrupt exception but does not appear in the return. The interrupted running task will receive interrupted exception but does not appear in the return list. The single starts and sleeps, correct. 2 to 5 are queued and not started. Calling shutdown now interrupts task 1 and returns task 2 to 5. How to validate interrupted tasks. To know which task actually got interrupted during shutdown, you need to track the running task separately by flag or logging inside the runnable. The return list from shutdown only contains tasks that were waiting to be executed, not the one currently running. So with 5 tasks and 1 thread, you always get 4 incomplete tasks because one is okay. So I have an idea here. Mm. Mm, 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 mm. So I will have a integer, atomic integer counter, okay, equals to new atomic integer of num tasks. Oh, sorry, num tasks. Where is it? Okay, and within each of this thread, I will say counter dot decrement. Okay, so it is supposed to decrement. Okay, and I will run it for, let's say, 500 milliseconds only. And what will I do next? I will make sure that okay, after thread.sleep 500 I am decrementing. So what I'm doing is I'm trying to do this decrement operation on the counter, but then I am doing a sleep of 500 and I'm interrupting, I'm like shutting down immediately, which means before even the 500-second passes, wait, let's give it like 5 seconds. Okay, before even the 5 seconds pass, I am killing the thread, right? So I'm killing and awaiting everything. Okay. So in the end, the counter value should be unaffected. It should be equal to the number of tasks. So that is my logic. Okay. So let's see. Let's see if that logic works. So counter after awaiting execution shutdown now. Okay. I should return. I say termination is there now. So after termination, this should be like this. So if awaiting execution is not equal to null, or like, okay, I'll do this. If shutdown now was called, use shutdown now was called, I will return this dot get equals to num tasks. Okay, this is not needed, this is not needed. Okay, and this should be here. Fine. Okay, I'll explain the code in the end once again. Let me run this and see. Yeah, everything would have been run by now. I should keep it somewhere over here. But anyway, I'll ignore it and run it for now. Would have failed anyway. Yeah, it failed because the debugger paused it for more than 5 seconds. So see, now it passed. Okay, so let's whiteboard it. Okay. How do I show both the ID and this at the same time? Never mind. I'll just explain it. Okay, so I have a counter and I said that is equal to num tasks. Okay, fine. So let's say what is the counter num task value? Num task is 5. Okay, so we have it here 5. So I have 5. Now I set this also to 5, this also to 5. Now I am starting 5 threads. Okay, let's say 1, 2, 3, 4, 5, And in each thread, I'm saying wait 500 or like 5000 minus I'm getting the value. 4 for some seconds later, doing doing shutdown. Counter should increment. That's what I'm well, should be no parameters that interacts by use past. And I should just in case of shutdown, it should be accident. Let's just say, yeah, that also failed. So I think it's fine. I see it buffering here. Okay, so if I run this again, hey, didn't even reach here. Okay, so what was that? Oh, I had my debug pointer disabled. Okay. Huh. So counter is still at 5. How? How is it possible? Hey, now it became. Oh, the debug pointer is making things run in parallel. Okay, so I will do one thing. Counter value. Okay, I'll assign it to a static thing so that okay, this will show the proper answer always. Debugger. Okay, now let's see. Control is 5 and numtask is also 5. Oh, so it didn't execute anything in case of shutdown. Okay. No, it is happening. See, it's got to. Let me see what is the value of you shutdown. False. Oh, so blocks until all tasks and after shutdown. The timeout is the thread is interrupted. Whatever happens first. Right. So even in this case, even in shutdown's case, it tries to shut down is what I am guessing. So regardless of whether you have it or not. Okay. Will this work? Right. So test graceful shutdown passed. So regardless of whether you're shutting down or shutting down now, I think it is getting interrupted properly. So the counter never gets decremented. It's always staying at 5. Okay, fine then. So that was the 15th question. One thing I noticed is, if you guys have questions, just post it in the chat. One thing I noticed is this one. Why is this failing? 13th question. We didn't do 13th question. This stream is 12 to 15. Oh, did we skip 13th question? Or did that happen? Okay, then let's do 13th question. Handling interrupted exception. Input leap millis. Output is true if task correctly handles interruption. Okay, so write code to submit sleeping task. There's some noise outside. Let me just close my windows and come back. Just a second. Okay, I'm back. So, where were we? 13th question. Handling interrupted exception. Input sleep millis. Interrupt delay millis. Is my screen? Yeah, my screen is fine. Write code to submit sleeping task, interrupt it, and confirm interruption handled. Okay. So we just have a single sleep task here. So executor service, I mean, service equals executors. Let me explain the code first. I mean, explain the question first. Okay. So they have two variables here, sleep millis and interrupt after millis. Now, what they, let's say they're saying sleep for 100 seconds or like 1000 milliseconds, but they're saying interrupt after 500 milliseconds. Now, if they said this, what should happen? The thread should get interrupted. So they started at 0 and they said wait, like sleep for 1000 millisecond, but they cut it at 500 millisecond. Now it should throw an interruption exception, like interrupted exception. What is the exception name? Interrupted exception. Okay, so interrupted exception. Okay, we have to make sure that this happens. So if at all an interrupted exception happens, we return true. So that's the whole gist of this problem. Okay, so let's try that. Yeah, let's try that. So we start with the normal executor service, executors dot single thread executor, and we do svc dot submit, like execute. We don't care what the return type is for now, and we do hey, in fact we do care about the return type. What we'll do is thread dot sleep for sleep millis. Okay, that will throw an interrupted exception, which we don't care. This is not the interrupted exception we are caring about. Okay, in here we'll do future of boolean, future. Okay, we'll return true. If an interrupted exception happen here, we'll return false. Okay, we will do interrupt after millis, right? So we'll do thread dot sleep for interrupt after millis. Okay, that will also throw an exception, which we don't care. Ignore. Then we do future dot cancel and interrupt it. Okay. When we say that, this will return a boolean which says, what does it say? False if the task could not be cancelled, typically because it has already completed. True otherwise. Okay. So if the thread got interrupted, this will first of all return true. But that is not what we are looking for. Okay. Cancelled, or like is cancelled, will return true. But they are saying to actually check interruption exception, right? I mean, like, well, probably doing get or something. So let's do future dot get. Okay. And that will throw us an interrupted exception. See this one. So this is what we are looking for. So if at all this happens, what we should do is return true. And hopefully this should be fine. So I'll do one thing. I'll say return is cancelled. Okay. Because is cancelled should also be true. And since it also got interrupted, we'll return true anyways. Let's hope it works. Let's see. Nope, it didn't work. Oh, it did a cancellation exception. Ah, because we cancelled. Okay, makes sense. Mm, so how do I call interruption then? Okay, let's try with shutdown here. Shutdown now. And svc dot await termination for like 1 millisecond. Okay. Now this should work is what I'm assuming. Let's see. We don't care about this also. I'm getting a lot of calls today. Just a second. Fine. So now if I run this, yeah, even that failed. Expected true but was false, which is confusing. I did a shutdown now. After this, how many hour time you want it to be? So why did it not get interrupted? Okay, let's see. Let's ask. Why does this return false? The method returns false because of how future get behaves when a task is interrupted and returns normally from its callable with a value. Okay. Aha. So what if I do this here? Can I? I don't even know. Uh, mm, uh, oh, I can return true here. Okay. So because I was catching the interrupted exception here, I think that is what the issue is. Okay, let me try again. No, it still didn't work. Task completed normally. When interrupted, the task catches the interruption and returns false. This means the task itself does not, it finishes normally with the boolean return value. Future at get since the task completes normally, calling future at get and returns that false without throwing any exceptions. Future at get only throws interruption if the thread waiting on get is interrupted. It throws execution exception if the task or cancellation ends cancel. Why your cache block for is not hit? Does not throw unless the thread that calls get is interrupted. Oh, the task handles. Okay, so we are supposed to do the try catch here only. That was correct. Where is the try catch? Right. Okay. This should have returned false. So when I do future, right? Did future fail? Okay. This should have returned false is my assumption, or like, yeah, so interruption exception happened, so this should have returned true, right? So our whole concept is true if task correctly handles interruption. So this task handle the interruption, so we should return true here, and then we got that variable here and we are returning it. Okay, I hope nothing else should go wrong. Yeah, finally. Okay, all everything executed. So the whole mistake that we did here is that I did here is I caught the interruption exception and I returned the value also. So when I do dot get here, where is dot get? Here, future dot get here, it returns that value of whatever happened during the interruption. I am supposed to check that value, but instead I'm checking interrupted exception here. This doesn't even make sense. So that we don't care about that. Okay. Now we have, so there is only one place. So you see interrupted exception is here, it's over here, it's over here. It's there in multiple places, but the only place where it matters is as in only place where we mind whether it got cancelled or not is within this future. So within the future, if at all the future gets, I mean, if at all the task gets interrupted, what should we do? Are we handling it properly? So that is the only variable that we are worried about. Okay. So if I run this again, we should get the same output. Okay, fine. So with that, all 15 problems are done. Let me mark it as done. This font, strike through. Okay. So I will commit all of this into, I mean, all of the 15 problems answer into this repo. The repo's link is there in this video's, this live stream's description. You can take it from there as well. And the problem solution, I'll commit it to the solutions branch. Okay, so just go here. And if you switch to the solutions branch, you will see the solutions. Nothing else. So with that, we end the multi-threading series, or maybe we have actually completed all the things that I planned for. There are only 2 levels which I was able to gather. There is apparently some more levels which my friend. So this whole question set was given to me by my friend, which I am actually using to study. So if I get more questions, I'll try to solve them as well. But then the next stream that is planned for is actually Java streams. You guys know Java stream concept in Java. That is what we'll be looking at next. Okay, so Java streams. This one. Okay, so that is going to be more interesting, at least. That is more easier to explain because things happen sequentially rather than this multi-threaded thing where everything is parallelly happening and it's difficult to even picturize what's happening. So if you guys want to watch that also, subscribe. If you like this video, like, drop a like and subscribe. Okay, so see you guys in that next session. I'm not sure when it is, maybe today night or tomorrow night I'll be doing it. Okay, so thank you all for joining. Have a nice rest of the day. Happy Diwali. Bye.